Alright, here we go. This is the last day to review for this test coming up. And here's number 13 from this section. Well, where do we begin? Something like this. What do you think? Okay, you can move the negative to the bottom. It would probably be the best thing to do. You have another choice too. You could have multiplied the two things on the top. But I think it'd probably be a best choice, looking at this problem, to take this and then move that to the bottom. I think that's probably the best thing to do right now. Alright, so let's do that. So if we move this to the bottom, we get 7 to the positive 2/3. Everybody see that? So it goes way up here, doesn't it? Cross it out if you want. And you see what's going to happen down here. You multiply these together. So what's the rule when you multiply together with the same base? Keep the base the same and do what to the exponents? Add the exponents, okay? We'll do that in a second. Let's move something else. Anybody else? Any ideas? X to the negative 9. Yeah, I'm going to take that one. Now, I guess you could move them both, couldn't you? You could take the negative 9, move it to the bottom, the negative 2nd, move it to the top. But it's really not necessary to do both of them. If you just take this one right here and move it to the bottom, this now becomes x to the positive 9th. And then when I multiply these together, I'm going to get a positive exponent, won't I? Everybody see that? So that's probably the best way to do it. So that goes away right there. Now we're ready to simplify these things. So on the top you just have 7 to the 3rd. I'm going to do step by step here, okay? I'm not going to skip any steps. This bottom one right here, we already discussed that. See these two right here? If we multiply these together, the rule says keep the base the same. So it's a 7. I just keep the 7 a 7. And then I add the exponents. So I just add these two things together. It's 2/3 plus 1/3. 2/3 plus 1/3 is 3/3. And 3/3 is the same as just a 1, isn't it? So it's as easy as that. Let's do the x's. Let's do this right here. Let's do this. Alright, so I got to multiply these together. Same rule, isn't it? Multiplying with the same bases, so I keep the base the same and I add the exponents. It's negative 2 plus 9, which is 7. Okay? One more step and you're finished. Let's simplify the 7s. You can't leave it like this. Don't leave your answer with the same base on the top and the bottom, alright, because it's not simplified. If I have the same base on the top and the bottom, I need to simplify it. So we can do that. Look, this means I have 1 7 on the bottom. This means I have 3 on the top. So one of these 7s will cancel with one of these. How many do I have left over? I have 2 of them. Okay, or you can think of it like this. 7 to the 3rd over 7 to the 1st. The rule is you subtract the exponents. 3 minus 1 is 2. So either way you look at it, you still get the same answer. So on the top is 7 squared, and on the bottom is just x to the 7th. Actually, I read it off 49 over x to the 7th, which probably is the best way to write it. But the book actually left it 7 squared. But I probably would prefer this way. Now, if you left it like this, I wouldn't mark it wrong. But some teachers might, okay? So you never know. You might go to college and you might have a teacher that will mark us wrong because it's not simplified all the way. All right, so that's probably the best way to write that answer. Questions on this? Anything that you don't understand about what we just did? Now's your time to ask. You guys are a very quiet class. Nobody? Okay, I'll trust you. Alright, that was 13. Let's do 14 now. Same kind of problem. Alright, here we go. This problem kind of looks like the other problem, doesn't it? You got negative exponents, you got fractional exponents, and all that stuff. You don't have any numbers for a base, you just have variables. You got letters for a base, but it's pretty much the same thing. So let's see. Look, they kind of made this real nice for us. I mean, look, they got the x's on top of each other, the y's on top of each other, the z's on top of each other. Okay, so it's, you know, they've got it organized pretty easy for you. So what we need to do is take a look at the x's and simplify the x's. So you got negative exponents on both of them, don't you? So I could move them both. I could take this one on the top, move it to the bottom. I could take the bottom one, move it to the top. But I don't have to do both of them. I only have to do one. Which one would you move in order to end up with a positive exponent? Which one? Top to the bottom, that's right. So let's take this one and then move that to the bottom. Let's see what we get. So if I move it to the bottom, I got to change the sign of the exponent. So if I do that, it's going to be to the positive 7/5. And that'll get rid of it. And you see what we're going to do now, don't you? We're going to multiply these together. We're going to add the exponents. We'll do that in the next step. Okay? So now, we've done this several times now today. So now you should get the general idea what we're going to do. Look at this one. I got a negative and a positive exponent. Well, obviously, I'm only going to move the one that's negative. So I'm going to take this one, and I'm going to move that one down to the bottom. If I move that down to the bottom, it's going to be y to the positive 1/3. And again, what do you do to the y's? You multiply them together, keep the base the same, you add the exponent. Alright, one more. This is positive exponent, so I'm not going to mess with that. This is a negative exponent. That's the one I want to move. So you don't always just take the top and move it to the bottom. You take the negative exponent and you move it to the opposite place. Okay, so it's on the bottom here. I'm going to move it to the top. So if I do that, I get z to the positive 5/6. See, it was a negative 5/6. I moved it to the top and I changed it to a positive 5/6. Right? Should have crossed that one out, crossed this one out. Now I'm ready to simplify this stuff. So let's do what's on the top. The base is the same, isn't it? So I can multiply them together. So I keep the base the same, and then I just take the exponents and I add the exponents to each other. So it's 7/6 plus 5/6. 7/6 plus 5/6 is 12/6, right? 12 over 6. What's 12 over 6? It's just a 2. Is this the same problem we did yesterday? Seems like we had a 12 over 6 yesterday, didn't we? Is it the same exact numbers? No, but that one was, though, wasn't it? We did have something that came out to 12 over 6. I do remember that yesterday. All right, let's take a look at these two right here. Let's multiply these two together. So I keep the base the same, and then I add the exponents. Jared, come on now. Write this down. If you write it down, you won't nod off. All right? You've got to write this stuff down. All right? So watch. Keep the base the same, and you add the exponents. So 7/5 plus negative 1/5 is the same as 7/5 minus 1/5, and that's 6 over 5. All right? It's easy fractions, aren't they? Because they're common denominators and all that stuff. They didn't make this difficult for you. They made it as easy as they possibly could, but still try to figure out if you know how to apply the rules here. Okay, let's do this one right here. Let's do the y's. Multiply the y's together. Same rule. I've said this rule probably 5 times already just today. When you multiply together, you keep the base the same and you add the exponents. 1/3 plus 4/3 is 5/3. So you just write it 5/3. And that's it. That's all you got to do. Yes, sir.
Are the bases going to be the same?
Yeah, they have to be. You can't do this if they're not. Right? If the bases aren't the same, you can't multiply them together. Right? You can't add the exponents. The only way that you can multiply these together is if the bases were the same. I'm telling you, the problems on the test are identical to the problems that you're doing right now, just the numbers will be different, that's all. All right? So the style of the problem will be exactly the same. All right? Yes. 11? Okay. All right, let's do 11. Let's change colors here. I'll just write this one out without pausing it. Negative 2/3. All right, here's number 11. We have a negative exponent again, but this is a little bit different than what we did before. We're not going to take this whole thing, move it to the bottom, but we are going to take the inverse of something. Okay, we're not just going to take the whole thing and throw it to the bottom. What we're going to do, if you have a fraction being taken to a negative exponent, we take that fraction and you flip the fraction. Take the reciprocal of that fraction. Okay, that's the first thing we're going to do. So I'm not going to worry about the 2/3. All I care about is the negative right now. Okay, so what I'm going to do is take this fraction and I'm going to flip it. So it's 8 over 3/43. Now, once I do that, that gets rid of that negative exponent. All right, so I flipped the fraction. I took the inverse of this, and then I took the inverse of this. Basically, I just kind of did nothing, right? I just did the inverses of both of them. So just like two negatives as a positive, when you multiply, it's kind of the same thing, right? I changed this, and I changed this. So that's to the positive 2/3. That's the first step. Not a difficult step, is it? I got rid of the negative exponent just by flipping the fraction. That's all I did. Now, this part's the part that's a little bit harder. So what I'm going to do now is, look, this is to the 2/3, isn't it? Well, what I'm going to do, I'm going to split it up and take it to two different exponents. What's the first exponent that I'm going to take it to? To the 1/3, good. All right, I'm going to take it to the 1/3. Now, where did I get that? Was that just a random number I just popped in my head? Of course not. Where did I get that 1/3 from? From this right here, okay? It's got a denominator of 3. So remember what I've said many, many times. I said take it to the 1 over the denominator. Okay, so the denominator is 3, so first of all, you take it to the 1/3 power. Now, of course, this and this aren't the same. What about that 2? What do I do with that 2? I got to take this whole thing and take it to the 2nd power. And that rule works, because if you look at it backwards, look, what's the rule when you take an exponent to another power? What do you do with those exponents? Multiply them together. So what is 1/3 times 2, or 2 times 1/3? It's 2/3, isn't it? So would you agree that you can break it up like this? Yeah, absolutely. All right? So that's the same thing. Now, why did we do it like this? Because they've rigged this thing. They've rigged this fraction so that I can take it to the 1/3 power. What am I doing when I take it to the 1/3 power? It's the same thing as taking the what of it? The cubed root of it. That's right. It's the cube root of this stuff. When I take it to the 1/3 power, it's the same thing as just taking the cube root of this. So you could use a calculator if you wanted to. Well, I know what the cube root of 8 is. You should all know that. We've dealt with that number a lot. What is the cube root of 8? It's 2, right. So that's going to be a 2. Now, 343 is not a number that I can take the cube root of that easily. So what did you say it was? 7? Okay. So if you didn't know it was 7, a couple ways you could do it. You could do cube root on your calculator, couldn't you? If I remember how to do cube root on this calculator, I don't use this very often. It's not that one. It's math, isn't it? Yeah, it's math. There's a cube root button right there. Do you see it? Okay. All you got to do, you could scroll down, right? You could go down like this. Or, if you're up here, you could just hit what? Hit the 4. Okay. So there it is. There's cube root. And then what do we put in there? 343. If that's easier for you, for goodness sakes, just do it like that, okay? And then there it is. It's 7. What if I wasn't sure if I did that right? How could you check? Well, I'll go 7 times 7 times 7, right? 343. So it is right, isn't it? So the cube root of 343 is just what? 7. Make sense? That wasn't that hard, was it? Use a calculator for that part. But what do I have to do with that? I got to square it, okay? Because I just took the cube root of these two numbers to get 2 over 7. But I got to take that whole thing and then square it. Why do I square it? Because you got this 2 right here. So I can do that without a calculator, can I? 4 over 49. That's it. Yep. 7? Okay. Any questions on 11 before we go to another one? Everybody okay with that? All right. Look, you got to practice these. You can't just sit there. I know I say this a lot, okay? But I want you to take this to heart. You cannot just sit there and just watch me do this. And even if you wrote it down today, that's not enough, okay? If you struggle with this problem, that is not enough just to sit there and write down what I just wrote down. Anybody, I could bring a first grader in here. They could copy this down. Now, they won't have a clue what's going on, but they could copy it down, right? Everybody could do that. But you've got to go home and you've got to find some problems that are like this. Where do you find other problems that are like this?
Book.
In your book. That's one way. Okay, you can look for odd. I would try to find problems that look like this, that are odd problems. Why do I pick the odd ones? Because what? Because the answer's in the back and you can tell if you did it right or not. Okay? Make sense? You can look at an old worksheet, right? Go back to the worksheet where we covered this stuff. I forget what section it is. You only have, well, you got a lot of worksheets, but you can look back, find the worksheet that covers this, and practice there. Okay, I've given you all the answers to that. So it's up to you. You've got to practice. You cannot just sit there and listen to me drone on and on and on and expect to know how to do this stuff. You've got to practice it yourself. Okay, enough pep talk. Number 7. What's that? This is the only one? Okay. All right, I'll just write it down. X squared minus 16. As soon as I see that, what pops in your head as soon as you see x squared minus 16? Difference of two squares. Doesn't that? Okay, it should pop in your head. You should look at that and say, oh, wait a minute, he's talked about that 100 times. Maybe not 100, but seems like it. So you should know what to do with that. And then let's look at this. All right. Now, this is a subtraction problem, and they're fractions. So the first thing that pops in your head when you think of subtraction or addition with fractions is to find a what? Common denominator. That's right. Now, if you try to find a common denominator with the way it is right now, it's really going to be difficult. Okay, I guess you could multiply them together. You could do this without factoring, okay, but it's going to be a lot more difficult. I think it's a lot easier to factor these things out first, okay? I'm not even going to show you how to do this without factoring because it would be ugly. So what we're going to do is just factor these first. That's the very first step, okay? I'm not even going to try to find a common denominator yet. I'm just going to factor them. And this should be something that you know how to do. It should be. I can't teach it from scratch anymore, but those lessons are on, why did I put 5? Those lessons are on YouTube, all right, on factoring. So if you don't know those, go back and look at them. Minus. Look at this next thing. Now this next thing is not a difference of two squares, but it is a trinomial factoring, isn't it? So you got to know how to do that as well. And I told you, when we first did that factoring stuff in the other, on the other section, whatever it was, I said you're going to see this really a lot through the rest of the book, didn't I? I don't know if you remember that or not. But just because we didn't officially teach this for this test, you still have to know how to do it, okay? Because it's a really important process. You know how to factor stuff. All right, up here. Wow, this is about the easiest factoring you could possibly do, isn't it? Except for maybe the difference of two squares. You got an x here. They're both positive, so that makes it nice and easy. They multiply to be 4 and add up to be 5. I only have two choices. I got 2 and 2, and I got 4 and 1. What's going to add up to be 5? 4 and 1, right? Okay, so that was an easy factoring. I hope it was for you. If it wasn't, if you didn't know what I just did right there, you've got to go back, search on the YouTube site to find factoring of trinomials. Okay, you'll find it, and I'll go through the whole process there. All right, so this is what we have so far. So now what I have to do is now I have to find my common denominator. I've broken these up into products, right? And it's a lot easier to find the common denominator with this. So I'm just going to put one big old fraction bar and put my common denominator here. So if you look at this, remember the problems where we found a common denominator? We kind of split it up into two columns here. Remember the little rule? Find out what shows up. Okay, it doesn't have to show up in both sides, but it has to just show up somewhere. So let's start with the first one, x plus 4. Is there any other x plus 4s? Yeah, there's one here. But there's one here, and there's one here, so how many do I choose? Just pick one of them. Okay, so I'm going to put that right here. Everybody see that? Just because it shows up twice, it doesn't really. It shows up once in one column and once in the other column. Okay. What else shows up? It doesn't have to be in both columns. Okay, it just has to show up somewhere. There's an x minus 4. There's none over here, so I just pick one x minus 4. What else shows up here in these columns? An x plus 1, so I pick that. So that's my common denominator. Right? We've gone through that little process before quite a few times. So now what we have to do is this. We got to figure out what is our what's our numerator going to be. I'm not just going to put an x here because I changed that denominator, didn't I? So I have to look. What did I do? What did I multiply this denominator by in order to get my new denominator? Well, what's missing? Yeah, an x plus 1, right? So what did I do to this to make it look like this? I multiplied it by an x plus 1 on the bottom, right? If I do that to the bottom, I also have to what? Do that to the top. I'll put it right here. So I multiply it by an x plus 1. See that? Really, I just multiplied by 1, didn't I? Remember that whole reasoning? Okay, I multiplied by a 1. So let's do this. Let's go ahead and distribute now. Is that all right? You want to do it right now instead of writing it down here? Yeah, we wrote it up here, so let's go ahead and distribute this. So let's get x squared plus what? X. Good, because it's x times 1, right? It's not just x squared plus 1, is it? You got to distribute that x through both of these things. All right. I'm going to get rid of this little bar right here. That's okay with you. All right, let's take a look at this denominator. What did we do to this denominator to get this new denominator? What's missing? An x minus 4, right. Okay, so what did I have to do? I multiplied the bottom by an x minus 4, so that means I have to do what? Multiply the top by an x minus 4 as well. Okay? Getting the hang of this so far? Now, here's a little bit of the tricky part. This might be the part that tricks people up more than anything. This is not just a 7, is it? It's a negative 7, isn't it? Right there. So it's a negative 7. You've got to be aware of that. That's very, very important. Even though that 7's kind of like way far away from that negative, it's still minus a 7. It's a negative 7, so you have to treat it as a negative 7. So let's distribute. But we're not just distributing a 7, are we? We're distributing a negative 7. Got it? So this is negative 7 times x, which is minus 7x. Now here's the part that a lot of people mess up on. So watch it so you don't mess up on this tomorrow. It's negative 7 times what? Negative 4. So it's going to be a positive 28. Okay? Does that make sense? All right, we're almost finished. On these problems, you don't need to multiply these three things on the bottom, okay? It's better, it just looks better if you just keep this exactly the same on the bottom. All right? It's not really going to simplify it, so I'm just going to keep it just like that. But on the top, they always want you to simplify the top one. So let's add some like terms here. Well, just x squared. The only like terms are these two right here, aren't they? So it's positive 1x minus 7x, which is minus 6x. And then you got a plus 28 on the end. And that's it. That's your answer right there. Okay with that? Does that help? Okay, it's being recorded, so go back and look at it tonight if you didn't quite get a couple steps there. I'm really trying to explain it as basic, as simple as I can without making it complicated. I'm trying. I don't know if I'm succeeding or not, but I'm trying. Anything else on here? We got a few more minutes. Last chance to ask some questions. Make sure you know how to factor. Look at number 4 and 5. That's all about factoring, isn't it? You can't get that right unless you know how to factor. So make sure you know how to factor. Number 2 is factoring. Number 1 is factoring. Number 7, the one we did, that's basically you got to know how to factor. All right, there's a lot of stuff. Let's do 20. We didn't do 20 yesterday. Let's do 20 today, since nobody else is asking. Okay, and we have to rationalize the denominator is what it says. So if we want to rationalize the denominator, we want to get rid of that square root in the denominator. So, oopsie daisy. All right, so what do we do? How do we get rid of that? Normally, we just take the square root of the bottom and the top, right? That gets rid of it. But is that going to work now, Leslie? What are we going to do now? Multiply by the conjugate. Very good. Okay. And you don't even have to remember that word conjugate. It's nice, just as far as communication with you and me, that that you can explain what we're doing. But what is the conjugate? 6 plus square root of x. Yeah, everything's the same except that middle sign right there. That middle sign just changes. Now it kind of looks like that difference of 2 square thing, doesn't it? So our outside and inside are going to add up to 0. That's what's nice about that. And what's going to happen is when I multiply these together, that will also get rid of my square root. That's the whole purpose of doing this, isn't it? Is to get rid of that square root. I can't just do that to the bottom, though. I have to also do it to the top. Why do I also? Is there a rule that says whatever you do to the bottom, you have to do to the top? No. All right. This rule right here, since it's being multiplied, we're just multiplying by a what? A 1. Right, because that thing in purple right there, that's why I was trying to do it in a different color, is 1. It's equal to 1. So let's go ahead and multiply these through. I always like to do the bottom first. I don't know why, but I do. You don't have to, but let's multiply these together. So really, the outside and inside will add up to 0. So all I got to do is multiply the first and the last. Let's do that. 6 times 6 is 36. Negative times positive is negative. Square root of x times square root of x is just plain old x. See how easy that was? Right? Recognizing that the outside and inside will add up to 0, all I got to do is the first and the last. It's a difference of 2 squares is basically what it is. Okay? Let's now take the square root of x and multiply it by this right here. Notice, I put this in parentheses. I did that for a reason. Why did I do that? So that you knew to do what? Distribute. Very good. Okay, so that you knew to distribute. So let's distribute. So if I multiply those together, now this is just a whole number, isn't it? So I don't put it both under the square root. I just go 6 square root of x plus, now look at this, square root of x times square root of x. We've already done that once in this problem. What is the square root of x times square root of x? It's just an x. And I'm done. That's it. Will that 6 cancel out with that 36? No, because this, even though the 6 is being multiplied by something, that term that it's a part of is being added to something else. Same thing with this 36, right? This 36 is being added to something else, so you can't cancel them out. That's the only thing you can do. Same reason with the x's. I can't cancel out the x's because they're being added, right? And I've said that rule over and over and over and over again, right? Till I'm about blue in the face. So make sure that you don't cancel those things out when they cannot be canceled. And that's how you get that answer. Again, I don't think that's all that difficult, do you? Right? 6 times 6, that's not hard. Square root of x times square root of x, that's easy, right? We've talked about that a million times. Again, maybe an exaggeration, a million, but you get the idea.
Not by much.
Not by much. It seems like it's about a million. Anything else on here? We got about 5 minutes. Anything else? 9? Okay. Oh, this might take all 5 minutes now. I'll try to go through it kind of quick here. What color would you like? What haven't we used yet? That red? We used that red yet? So number 9. Here we go. Here we go. First thing I want to do, now I put this over 1. It was written just plus p, right? But I put it over 1 so it looks like a fraction. So first thing I want to do is find a common denominator. But before I do that, I need to simplify that. We did a problem like this earlier, didn't we? So watch. It's going to be 4 over, this is a difference of 2 squares, so it's p plus 9, p minus 9, plus p over 1. Don't forget this denominator. Remember yesterday I forgot it? So I learned my lesson, didn't you? So let's do this. Let's find a common denominator for this stuff. See, what I'm doing is I'm trying to add this stuff together right here. So I got to find a common denominator. Well, that common denominator is going to be p plus 9, p minus 9. Right? So now, what did I do to this? I didn't do anything to the 4, did I? Plus, what did I do to 1 to get to this? Well, I multiplied it by p plus 9, p minus 9. Right? I did that to the bottom and I did it to the top. I just wrote it down right here, kind of skipped a little bit. Now that whole thing is over 1 over p plus 9. Let's do this. Let's simplify, because the way they write the answer, let's simplify this stuff right here. So it's 4 plus, I'll tell you what, this right here was what? It was, I'll just make it a little shorter. It's p squared minus 81, isn't it? Now it's being multiplied by p, agreed? So what's that going to give you? P cubed minus 81p. Got it? Over p plus 9, p minus 9. Now let's do this. I don't need to write it over all this stuff because I know what I'm going to do with this. What am I going to do with this? I'm not going to divide by it. I'm going to multiply by what? The reciprocal. So the reciprocal would be p plus 9. Put it over 1. Everybody see that? Now look. All this stuff right here is being multiplied by this thing right here, right? So this is in parentheses, that's in parentheses. They are being multiplied. Even though there's a plus sign in here, this whole term is being multiplied by this. So guess what I can do with this p plus 9? Cancel it out with that p plus 9. And then I'm left with my final answer. So it's 4 plus p cubed minus 81p over p minus 9. That's it. Wow, did that pretty quick. All right, there you go. That's the test. You can't say that you weren't prepared for this, can you? There's no way in the world. There's no way you can, you can say, well, my son, my daughter wasn't prepared. They didn't have enough time to learn it. No way. All right, I've given you more than enough time to prepare for this stuff. So it's up to you now. Okay, it's up to you to put in some work, put in some review, and do these problems tonight. Don't look at each other when you get to the locker. You ever do this when you get to the locker and say, what do we have tonight for homework? Did we have math? Oh, no, we're just taking a test tomorrow. No, say study for the test. Take your worksheets home. Do problems, okay? You should be doing some problems tonight. Just because we're down to test tomorrow doesn't mean you shouldn't be doing it. How do you study for a math test? People ask me all the time. How do you study for a math test? You can't study for a math test. Yeah, absolutely you can. You study for a math test by doing problems. That's how you study for a math test. You don't just sit there with a book in front of you and just read the chapter. That is not studying for a math test. Okay, that would be ridiculous. Do problems. That's how you study for a math test. Everybody got that? Okay. I expect good things tomorrow. I do. Don't disappoint, okay? Put some time and effort into this, all right? Because I sure have. Okay, I've busted my rear end, put it politely, to try to get you to understand this stuff. I really have. I think I've gone the extra mile. So you need to go the extra mile and do it. That's right. Okay. Good luck tomorrow. Study hard tonight.